Marc, what does becoming a Max Planck Fellow mean to you?
So first, it's a great honor, and I think it's a great recognition of my work that I can have this group here and be nominated as Max Planck Fellow. Also, it offers me like new opportunities to do better research, continue my research with more people and more equipment, so I can set up a new lab here with new robots and hire a couple of new people.
Speaking of lab, your group will be named the Physical Reasoning and Manipulation Lab. What research do you plan to conduct in the coming years?
So I think one way to explain it is to talk about what in cognitive science people call intuitive physics. So people, also animals by the way, they have this capabilities to reason physically. They use tools to solve things. Like in YouTube, you can see these videos where a crow uses sticks and kind of wires to solve little problems. And we humans, we can play all these physical games and solve these problems. And the question is, how does this work? What kind of algorithms or what kind of principles are behind this physical and geometric reasoning? And I'm kind of thinking about algorithms, also robots that could do the same thing.
So robots with intuition, how does that work? How do you teach a robot what intuition is?
Well, in that case, I'm talking about physical intuition. It means that the robot would have an anticipation of what happens if he does something physical. If the robot would face the task like build some construction, let's say build a tree house in the woods or so, then he would be able to conceive and like visually and geometrically conceive of how that tree house would look like, and then be able to conceive of what kind of materials, what pieces would I have to take, and how would I have to assemble them to actually build that tree house.
How does your research differ from others?
I think one of the things I find important, and that maybe I'm recognized for, is to try to do bridges between disciplines. So to not only be dogmatic and only work on machine learning, or only work with neural networks, or only work on classical AI planning, but actually like combine these things. And I always think that the most important part of research is that you identify the real problem, and real means like a real scientific problem or a real-world application problem, and then use tools from all the disciplines, or combine the theories and methodologies from all of these disciplines.
Looking many years into the future, you have long retired. What will the scientific community know you for? What will be your legacy?
That's a tough one, really. Maybe there is two things that people can be recognized for. One thing would be one concrete result and one algorithm. If it would be that, that'd be great. But actually also, I think if I think of other like professors that I think of very, very highly, usually it's not like one piece that they're being recognized for, but more like the knowledge and the deep knowledge that they have about the whole field. And maybe I'm going to be known for that.
Marc Toussaint, thank you so much.
Thank you.